Cooking generally involves getting food hot, which can occur through convection, conduction, and radiation. Thermal energy is transferred, and in this example, we will see conductive energy transfer with this saute pan, with this pot of boiling water, and a microwave to show radiation. Now, with conduction, this is the direct transfer of heat, and it transfers the heat directly from the surface to the adjacent molecules. Heat is transferred from the molecules of the hot surface to the molecules of the adjacent pan, and then from the pan to the food inside the pan. And we're going to be using onions to show this bad boy is hot. Start to hear the sizzle. See that we get some heat is being transferred from the burner to the pan into the onion. Conduction is a slow method of heat transfer, but it's direct, and the food ends up having a cooked outside and kind of a soft, juicy inside. Now, over here we have convection. And convection is the heat transfer through gases or liquids. And it's actually a combination of conduction and convection, and then mixing that the gas or liquid is heated up at the source down here at the burner. And so that's heated up through conduction, and then convection, it heats the hot becomes less dense, and it kind of moves up, and the cooler portions of the water come down to replace it, and it creates this this cycle. In the pot of water, conduction introduces the heat, and the onion that we're going to use over here is going to then have the heat transferred into it. It's actually heated up through convection, and then once it hits the onion surface, then it's going to hit back and get into conduction to cook the inside part of the onion. Next, we have radiation, and with radiation, we're going to show that with popcorn. Now, radiation is the transfer of energy through waves of electromagnetic energy. Waves moving through space hit matter, in this case the popcorn, and are absorbed, causing the molecules to vibrate, increasing the temperature. In the kitchen, there is microwave radiation, which we have going on right now. And microwave radiation causes the molecules to vibrate, like we said, going faster and faster. And this actually cooks faster than infrared radiation because it cooks further into the food. Infrared radiation is, for example, like a charcoal or in an oven. The waves of radiant energy travel from these sources into the food, as we can hear with that popcorn going. Another thing it shows is if you had a glass pan and you were to go in the oven, then because the glass is transparent, it allows the radiant energy to pass through it. So then, say if you were to use it, there's additional energy put into the pan, so you would want to have, say, use less time. So as we can see, the transfer of thermal energy is very important to cooking, and it creates lots of different ways to make delicious food. And as we can see, the popcorn came out, and that was the radiation. So we have conduction, which is the direct transfer of heat. Convection, where we have it through a liquid or a gas, and it's moved around. And then radiation, where we have the transfer of energy through electromagnetic energy, so it's moving through waves. And that is the transfer of energy here in the kitchen.